So this exam style question is going to be on fluorescence. So a fluorescent tube is filled with mercury vapour at low pressure. After mercury atoms have been excited, they emit photons. So in which part of the electromagnetic spectrum are these photons? Now I remember learning that in our fluorescent tube, we remember seeing that these mercury atoms release ultraviolet photons. So that's the answer to that question. This is just something we have to know, unfortunately. We have to be able to remember these facts about the fluorescent tube. And we supplement this all with our general understanding of excitations and de-excitations, etc. But there are some facts we just need to know, like the fact that mercury atoms emit ultraviolet photons once they de-excite after big exciting. We're also going to need to know how they excite in the first place. So let's just write that down. So the first answer is just ultraviolet, is all they want there. So what is meant by an excited mercury atom? Well, that could just be an answer to what is it meant by an excited atom in general, and we know that just means that electrons move to a higher energy level. So we see that an electron in the atom has moved from its ground state to a higher energy level. It's just one mark. They just wanted to make it clear that we said electron and that it moved to a higher energy level. So how do the mercury atoms in the fluorescent tube become excited in the first place? So for that we need to go back again to what we did on fluorescence, and remember they were excited by colliding with free electrons in the tube. Specifically, they collide with the orbital electrons in our mercury atoms, just as we were seeing in excitation by collision, right? These electrons collide and transfer energy to these electrons and then move them to a higher energy level. So that's what the answer is there. So what we see is that free electrons in the tube collide with atomic mercury electrons, transferring energy to them and moving them to a higher energy level. That's what we get for our 2 marks there. Stating what does it, free electrons, and the fact that they transfer energy, which moves them up to a higher energy level. So our next question is why mercury atoms emit photons of characteristic frequencies at all. And remember, that's just back to what we were saying with these de-excitations, the idea that atomic energy levels are as fixed, discrete, and so electrons can move between these energy levels, but when they do, they have to emit specific photons with specific frequencies. And so we can write that down. So what we say is that mercury atoms have specific discrete energy levels. When electrons move down levels in these atoms, they emit a discrete amount of energy in the form of a photon. These photons have frequencies proportional to their energies, and so only a certain set of frequencies can be emitted. And that's all they were looking for there. So our next question is just going to be some calculations. So the wavelength of some of the photons emitted by excited mercury atoms is 254 nanometers. The first thing we'd like to do very simply is just calculate the frequency of the photons.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.